Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, let us solve the next question, question number 27 of JEE Advanced Physics Paper 2015. So let us start with question 27. Hello students, let us solve this question number 27. An electron in an excited state of lithium plus 2 ion, so doubly ionized lithium atom, has angular momentum of 3h over 2 pi. The de Broglie's wavelength of electron in this state is p pi a naught. P pi a naught, where a naught is the Bohr's orbit, Bohr's radius, first orbit obviously of Bohr radius. The value of P is Bohr radius corresponding to this third transition. Now, de Broglie's wavelength of electron in this state is this. So to find the de Broglie wavelength, we know that the de Broglie wavelength lambda is h over p, which is h over m into v. This is the momentum of the electron under consideration. Now, from Bohr's postulate, rather second postulate, the angular momentum of the revolving electron, that is mvr. When an electron revolves in a circular orbit, then the angular momentum will remain constant and its magnitude is mvr. That is nh upon 2 pi. Here it is 3h upon 2 pi. It's given 3h upon 2 pi. This justifies that the n value is 3. The given question, if I compare this, n value is found to be 3. So, electron is in third orbit of Li plus 2 ion in excited state. So this is n being 3 here. Now I will write MBR as 3h over 2 pi, and from here MB is 3h over 2 pi r. This MB, which is 3h over 2 pi r, is substituted in the first equation. Suppose this is equation number 2. Put 2 in 1. What you'll get? Putting 2 in 1, put 2 in 1, will get lambda is h over mv, and the mv we got as 3h upon 2 pi r. So from here I'm getting 2 pi r over 3. This is the value of lambda I'm getting. Now again, suppose that this is equation number 3. Now the de Broglie wavelength of the electron in the state is p pi a naught. A naught is Bohr's radius. So I have to express this radius of the electron in the third orbit of lithium ion in terms of the Bohr's radius. So we know that the Bohr's radius and this r can be represented as, that is a naught n square times the z value divided here. Generally r is proportional to n square, so it is Bohr's radius, first Bohr's radius for this is A naught is for first orbit, this is for third orbit, so it is n square, that is 9 divided by, this is A naught, n is 3, so it is 3 square because n is 3. Divided by Z for lithium is 3, so it is 3 over there, so this 3 cancels out and it becomes 3 A naught. This is the radius of the third orbit of lithium ion, and this R I will put in equation 3 in this equation, then I'll get lambda equals to 2 pi over 3, R is 3 A naught, so obviously this will cancel out and this becomes 2 pi A naught. So when you're getting lambda is 2 pi A naught, this is we obtained, this relation is obtained, and what is given? Lambda is 2 pi A naught is obtained, and what is given is lambda is p pi A naught. You can see here lambda is p pi A naught. This is given in the question. Comparing these two, so obviously you can write that this p will become 2. So the value of p is 2. This is our answer. So this value of p is how much? The answer is 2. This is the answer. Okay, thank you.